I'm Mark Sponsler, and welcome to the Stormsurf Videos Surf Forecast of the week starting Sunday, August 15th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we don't see really anything going on. A gale is trying to develop south of Tasmania, producing 32-foot seas, and scheduled to push up into the Tasman Sea somewhat. But other than that, nothing is going on. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When the gales form, help direct their track. We're looking for a trough that is a push in the southern branch of the jet. So there's two branches, the northern branch up here, the southern branch sort of ill-formed wandering around down here somewhere. And there is actually a trough right here. There's New Zealand, there's Australia, Tasmania there. And there is, what is that, about 130 knot winds pushing up into that trough. Anyway, what a trough does is when it gets in this configuration, it helps create a clockwise flow aloft and down at the ocean surface. And in the southern hemisphere, that's the hallmark of low pressure. Low pressure, of course, we know, if it's deep enough, starts generating winds. Winds, if they're strong enough, start generating seas. And seas, if they're high enough, as they radiate away from the fetch area, turn into swell. So troughs are a good thing. So we have one little trough here, but you see the jet just kind of falls apart. There's very little energy associated with it over the entirety of the South Pacific Ocean, and whatever energy there is radiating up out of Antarctica. So no obvious signs for support for gale development other than there in the Tasman Sea. So we get into Monday, that trough continues somewhat into the Tasman Sea, trying to push its way under New Zealand, but then it just starts getting pinched off and falling apart as we get into Tuesday. And it's pretty much gone, and what you see the beginnings of is a ridge. That is the opposite of a trough, pushing south, and you get this sort of pronounced split jet stream flow, and between those two flows you end up with high pressure, and that doesn't do anything for generating swell or surf. And you can see as we get into Thursday, the split flow, pretty pronounced. The ice line somewhere around 62 south, something like that. So there's not even really any clear space to support gale formation. And then the ridge only starts building as we get into Saturday and then Sunday, pretty much eliminating any real obvious signs for support for gale development. I'm sort of looking here at a little bit of a trough that's trying to organize on Sunday even, but it's pretty much out of the California swell window, so even that doesn't offer us any hope. This time of year, one normally would start looking north in the North Pacific, and the jet stream there, not in bad shape, but just nothing organized is forecast there at all. So we'll continue to focus on the southern hemi. So then we take a look down at the surface. Surface level pressure, surface level winds. As expected, there is a growing low pressure system here. What is that? 72, maybe 964 millibars, something like that. Developing the deep South Tasman Sea with 40 knot winds, but all pretty blocked there by Tasmania for the moment. But as we get into, we'll say Monday, a decent fetch of 35 to 40 knot wind starts pushing up into the Tasman Sea. That would do something for Fiji, but that's not really our main forecast area. And even that gale starts fading out as we get into Monday night. And you see there is fetch, 35 knot fetch Monday night, but all aimed south at Antarctica. So no hope there either. More the same as we get into Tuesday and Wednesday. Little gale tries to develop right north of the ice line here on Thursday morning. But 50 knot winds, but it's falling southeast. You really need to be pushing up to the northeast, and it's not doing that. And then another bit of fetch on Saturday in the 35 knot range, but all aimed southeast again and of no real interest, because the jet stream is pushing south, and that just sets the tone for everything. That's why we focus on the jet stream, because if you can get something going out of the jet stream, now here we go, as we get into Monday, that little trough we were looking at here on the very edge of the Southern California swell window, maybe generating something, but that's a week out. So again, it's the jet stream sets the tone, and everything else down in lower levels of the atmosphere follows its lead. And if you don't see much in the jet stream, typically you don't see much down at the surface. And it is, of course, winds on the surface of the ocean that generates waves, not winds high up in the atmosphere or stuff going down deep in the ocean. It's right at that interface of the air and the water. Now, all that being said, that doesn't mean that there isn't swell in the water, because clearly there is. In fact, there's been waves the past couple of days, good little swell overhead at select spots in Santa Cruz area Friday and Saturday, so not bad. That swell's starting to fade out now, though. But another gale developed east of New Zealand on Monday night a week ago. This is sort of like a pre-gale. It wasn't really even the main event, but this little thing, 28-foot seas, has generated swell radiating north towards Hawaii, and then it sort of metastasized. And by Tuesday night, we had 35.8-foot seas modeled right here, and then building quickly from there. By Tuesday night, seas were 39.6 feet. This is the highest seas over the whole domain in this image. And then continuing at 39.2 feet, and then slowly fading off as we got into Thursday with 32-foot seas and fading out from there. As everyone is probably aware, large swell has hit Tahiti. Solid looking waves, bigger, or not bigger, but approaching the size of the Code Red swell, have hit. Now the question really is, well, how often were the sets that big? And from little bits of rumors we heard, those were for sure the outlier sets, the biggest of the biggest. It was not consistently that big, so don't get yourself overly excited. Not needless to say, though, the sets that did hit were unbelievable, looked quite large, quite solid. Decent swell is radiating north towards Hawaii and the U.S. West Coast. That said, Hawaii, in fact, we'll go back and take a look here. Let's do this real quick. We'll just talk for a second. There we go. Hawaii's Oahu's at like 158 west. The core of the fetch was at 158 west. So whatever swell they're going to get is going to be what travels due north and not off at an angle. You really, for Hawaii, you want the core of the storm to be more over here. That gives it a little bit more momentum versus kind of almost being sideband swell radiating north. That said, still decent swell is expected for Hawaii. Relative to California, bit of shadowing here from the islands. Depending on which calculators you use to calculate the Great Circle Pass and where the trajectory exactly goes through the islands, the shadow can be more or less relative to Northern California. Not so much for Southern California, but still a little bit of shadowing will occur. That typically reduces the number of waves in a set, cuts some of the size out. But with the storm that did let's just play it here, did like this, built, pushed a bit to the northeast and held with good size, decent swell certainly is expected to result. And then there's the other factor here is, so this is the Jason 3 satellite pass. This is the wave model for the 0-hour run of the wave model on Tuesday night as the storm was getting developed. With here 30, 32, 34, we'll say 35-foot seas right in the core. The satellite pass just west of the core. But notice this, you can see these grays here, and then we'll pull this up here so you can see the average of 15 of these readings, and these readings are far thinner sliced than what it appears in this image. I mean, they're very small. 41.6 feet, where the model said seas were, we'll say 32 feet. And one of the slices, the highest slice in here, 49.7 feet. So the short of it is, it looks like the model is actually underestimating, or actually underestimated sea heights. And then again, 18Z on Wednesday, the same sort of thing happened. Here, we'll pull it up. There we go. It's 30, 32, 34, 36, 37-foot seas. But the satellite said It got a average reading of 43 foot right in this area, with one reading to 46.9 feet. So again, the model underperformed in actuality. What happened? Seas were actually higher than what the model was saying. So that might help a bit to filter out or improve some of the detrimental effects of shadowing and give a little bit more energy pushing into California and Hawaii. That said, peak swell sizes in Hawaii are forecast. I think it's right around 3 feet at 17 seconds, and about the same for California, 3 feet at 16 and a half, 17 seconds, something like that. We did some manual calculations where we suspect maybe more in the 4 foot range, or some sets 4 feet at, let's say, 17 seconds, which would make it a significant class swell. But we'll stay conservative, not to get too overhyped. We'll say 3 at 17 for most locations, which is overhead surf, but not tremendously so. Don't be thinking code red swell, because there's no expectation that's going to happen. For one, the code red swell seas were much higher, the storm was much broader, much larger, lasted longer, all that kind of stuff. But a solid swell, probably the biggest of the summer so far. So then, let's move on. What else is coming? Looking at the forecast for the Southern Hemi, the wave models here, you can see not a whole lot going on. Where are we? We're Wednesday, going into Thursday, going into Friday. We're just looking for anything we'll give it 28 feet that's in our swell window. We're not seeing it at all. You get, there's 30-foot seas over a tiny area, but pretty much aimed southeast, traveling southeast, and we're a week out. Ice line, yeah, about 62, 63 south, but up to 60 over the central South Pacific. So there's not much space here. Earlier this, in the spring, it's down around 68 or so, something like that. So we're at the peak of winter in the Southern Hemisphere, so not a lot of room for storm development. Next up, we take a look for wind swell development. Of course, the thing that grabs your eye, Hurricane Linda down here. We're going to talk about that in just a second. The short of it is, tiny swell, 12-second, 13-second period energy is radiating into California, Southern California pretty much as we speak right now, from when Linda was back here. But let's focus on just wind for right now. High pressure, somewhat in control, 15-knot winds north of the Hawaiian Islands. Not really doing anything in terms of generating wind swell for east-facing shores. And California, 15, 20-knot winds over northern California. But again, still pretty much small wind swell is the best that we're really seeing. As we get into Monday, the picture for California improves a little bit. 20, 25-knot winds. That should generate more wind swell. Nothing for Hawaii. Get into Tuesday, more of the same, building fetch of 20 to 25, almost 30-knot winds off of northern California, Cape Mendocino area. So improving wind swell potential. So we get into Wednesday, again 30, it was almost 35 knots in the evening, Tuesday evening. So better wind swell, but notice this, that you have high pressure out here, heat low inland, that produces the gradient. The isobars, these lines, get closer and that generates the wind. But it also looks like it's entirely possible that we could have a southerly flow along a good portion of the California coast, an eddy driven by this low pressure here. And that is pretty much the game into Thursday and Friday as swell, the southern hemiswell, approaches California or is hitting California. Fetch and north wind swell, at least in the north end of the state, but down south, a lighter wind regime, and probably that wind swell won't mar the swell significantly. Remnants of Linda pushing off as we get into Friday and Saturday north of the Hawaiian Islands. Will it produce some wind swell? Yeah, it entirely possibly could. Is it going to be huge or anything? No, we're not seeing any of that. Another system forecast down here. We're out a week from now. Do I believe it? No, not for a second, especially with the GFS model. Couple days out, maybe so, but beyond that, no. So wind swell, southern hemiswell look like the main focus for California, and then, of course, the southern hemiswell relative to Hawaii, but that would mainly be in the early part of the week. The forecast for Linda, and actually we'll go back a little bit. The part of Linda that generated swell was Friday and Saturday, right here in these positions, winds were about 100 knots. Seas were in the 28 to 30 foot range. 12, maybe 13-second period swell should be starting to hit Southern California about now. Continue into Monday and Tuesday, but we're talking 2 feet at 13 seconds, something like that. So waist high, maybe chest high surf at top spots. And from a really southerly angle, like 165, maybe 170 degrees. So only for exposed breaks. Northern California, we're not really expecting to see anything at all of any meaningful value. Hawaii, probably not, but you never know. We'll see what happens in the next day or two. And then in the northern hemi, this is a week ago, last Sunday, a little tropical system pushed north or east off of Japan, making, it's at 31-foot seas, and then another one behind it produced 27-foot seas. What was that? 28-foot seas. Okay, like 1 pixel worth of 28-foot seas. The first swell from this first system is hitting Hawaii as we speak. Second one to come in over the next several days. I mean, swell-wise, not anything particularly huge on north-facing shores. Again, 2 feet or so at 14 seconds, something like that. That said, we saw some waves in the shoulder high range at select spots on the North Shore this morning right after sunrise, and it was only supposed to come up a little bit from there. So rideable surf, first little taste of fall for the islands, but nothing too much to get excited about yet. And just a quick look at temperature profile in the mountains and potential for any winter-like or fall-like cold fronts precipitation potential, and there literally is none. Temperatures still, freezing levels still above 14,000 feet across the Sierra, so no sign of fall in the immediate future. Let's go take a look long term, what's going on with the Madden Jullian Oscillation and the El Nino Southern Oscillation. As usual, we start for looking for signs of the active phase of the MJO, the Madden Jullian Oscillation. It is this periodic weather oscillation that travels on the equator from west to east. The active phase is on one side of the planet, the inactive phase is on the other side, and they travel in direct opposition of one each other around the planet. The active phase is what we're looking for because it acts like a low pressure system, and by doing that it creates clouds, it creates uplift, it creates precipitation, and it fuels energy into the jet stream, which then in turn feeds the storm track, which then of course creates low pressure systems and storms either in the southern or the northern hemisphere. The inactive phase does the exact opposite. It is like a high-pressure system, and it steals energy from the jet stream and doesn't completely stomp on storm production, but generally makes it less favorable. So the idea is to look for signs of the active phase of the MJO and see if it's moving over the Pacific, and specifically in the West Pacific, because also if it's strong enough when it's there, it can create Kelvin waves. And Kelvin waves essentially are large pockets of warm water that traverse the Pacific from west to east under the ocean surface. And if you have successive Kelvin waves driven by successive active phases of the MJO, they can kick off El Nino, and everyone knows that El Nino is great for generating large surf. All right, so first off, we look at data from the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here. This is the West Pacific here. There's the equator right there. We're looking at the arrows. The buoys have wind sensors on them. They report 5-day average winds. So you see the arrows here out of the east, strong out of the east. In the East Pacific, moderately east over the Central Pacific, and in the West Pacific, the Kelvin wave generation area. This is when the active phase gets over here. If it's strong enough, this is where it produces Kelvin waves and where it does its best to feed energy into the jet stream. Winds out of the east, but it is not the actual wind, it is the anomalies, differences from normal, and that's how you tease out where the active phase is, or to see if it's even in the Pacific. In the East Pacific, winds are out of the east. The active phase can reduce or completely reverse trade wind direction, so no sign there. Over the Central Pacific, one arrow out of the west, but everything else pretty weak. And over the Kelvin wave generation area, the arrow is still out of the east, so real no sign of the active phase of the MJO. All right, so what have the winds been doing? Anomalies, not the actual winds, but the differences from normal for this time of year. So we have 5 different charts, 5 for the past 5 days. Let's orient ourselves. South America there, Central America, Mexico, Hawaii, right there. That little just looks like a couple of specks. Equator is at 0. Okay, Philippines, New Guinea right there. Kelvin wave generation area. Right there, that's where we're interested. See the blues and the arrows coming out of the east, so easterly anomalies. Winds stronger out of the east than normal on the 9th, on the 10th of August, the 11th, building, if anything, the 12th into the 13th. So this sort of suggests the inactive phase of the MJO is setting up over the West Pacific. This is the forecast for the next 7 days. The whole planet on one chart. The date line runs right up the middle here. Time down this side. Okay, so Kelvin wave, the far West Pacific, the far parameter of the or the boundary of the Kelvin wave generation area, about 135 east. So right there, you can go the whole way up the chart. And then the westerly or easterly boundary is at 170 west, just past the date line. So right here, and you go right up there. Okay, so you can look back and see, well, it's been, and the yellows are westerly anomalies, the blues are easterly anomalies. So you see kind of a mixed, no clear sign of the MJO in July and the early part of August, and then you see this big batch of blues. That is easterly anomalies. A clear sign of the inactive phase of the MJO started about August 10th and has been building and is forecast to build entirely through the next week, filling the Kelvin wave generation area. So it's no wonder that the wave models are showing literally no swell production happening, and that the GFS model is showing the jet stream depressed way to the south, not supporting gale formation, all driven here by the inactive phase of the MJO. You wonder why we harp so much on this stuff? Because if you understand it and look at it, you get a really good sense of what's going to happen a week, 2 weeks, 3 weeks out. Even though the GFS model itself, we say don't believe it more than 2 or 3 days or 4 days out, but you can get general trends, maybe not the details, but just looking at this, I don't see anything that looks favorable to support storm development for the next week. Of course, that doesn't mean there isn't swell in the water, and clearly there is. But after that, this kind of makes you wonder, well, maybe we're going to go into another one of these 3-week periods where there's no surf. That's probably the case unless the North Pacific somehow magically wakes up. All right, next up, outgoing long-wave radiation. Fancy words for cloud cover, right? If the inactive phase of the MJO acts like a high-pressure system, then high-pressure systems typically don't have a lot of clouds associated with them. Clear skies, a lot of sunlight reflectivity off the ocean surface. That is depicted in this image as oranges and yellows, okay? So the equator is right there. South America, Central America, Hawaii there, New Guinea. Kelvin wave generation area right here, the all-important part of the Pacific Ocean. So inactive phase of the MJO now, also forecast 5 days from now, 10 days from now, 15 days from now. So 2 weeks. Per this, the statistic model, no clear indication of the active phase of the MJO showing up. That said, the GFS model, GFS ensemble model, suggests, well, maybe things aren't that bad. Maybe about a week from now, the inactive phase is going to dissipate, and a weak active phase starts pushing into the West Pacific. So that gives us some hope for maybe 2 weeks from now. The jet stream will get a little bit more energy. It'll start lifting north, and maybe the southern hemisphere will liven up a little bit. The same two models, statistic model here, dynamic model here, but just a different view. So the MJO moves west to east from the Indian Ocean to the maritime continent, to the West Pacific, East Pacific, under the United States, on the equator, across the Atlantic, over North Africa, back to the Indian Ocean. The stronger the active phase is, and this only maps the active phase, its position will move further to the outside of the image. So a weak MJO will be in here, a stronger out here. The heavy dot is where the active phase is right now. So North Africa, or the far West Indian Ocean. And then these are the three different forecast tracks putting the active phase 2 weeks from now in the central Indian Ocean and exceedingly weak inside the circle, not even outside of it. So a moderate active phase right now. The dynamic model says pretty much the same thing. Maybe the active phase making it to the maritime continent, but still extremely weak. So neither one offering us piles of good hope for the moment. The upper level model paints the image very starkly. So this is, let's get ourselves oriented, 8 different panels, each of them the same area, showing the trajectory of the MJO across the Pacific, or really around the planet. South America, Central America, Hawaii right there, New Guinea there, the equator right there, and the Pacific, this whole area. Oranges are the inactive phase, dry air, okay? Wet air, the active phase, over the Atlantic. So if the active phase is over here, over the Atlantic, that helps fuel tropical development. One would be looking for the Atlantic basin to certainly be awake right now and producing tropical activity, which it is. Fred and Grace, both in flight right now. Neither of them forecast to get particularly strong, but, strong's a relative thing. If you're sitting under a storm with 40 or 50 knot winds, that is not pleasant. All right, but in the Pacific, back closer to home, dry air, significant dry air filling the Pacific basin, no surprise, inactive phase of the MJO. It's forecast to make its trek across the Pacific, moving across Central America, we'll say September 9th right there. And about that same time, the active phase is supposed to start moving its way into the Pacific and making its trek across there. So the whole month of September is looking like a good target for storm production. Given that time of year, then maybe it would be northern hemistorm production versus southern hemistorm production, or maybe a combination of both. The MJO does not discriminate, though its correlation, or it does its best manifestation in the northern hemisphere in the winter, but the active phase can also do a pretty good job of fueling storm development in the southern hemisphere during our summer months. All right, so let's go out a month. CFS model. Now we're looking back down at the ocean surface. We look at a lot of different models, but the idea is not every model is right. Some have their strengths, some have their weaknesses. You take all the data, you put in a bag, shake it up. You weight it towards the models that tend to be more accurate and unweight the data points for those models that tend to be less accurate to sort of build your own personal forecast. All right, so whole planet on one chart again. The date line runs right up the middle here. Time, of course, there. Kelvin wave generation area. West Pacific starts right about here. 135 east, goes the whole way up to about 170 west right here. And, okay, so we're looking at the blues. Blues are easterly anomalies. Oranges, reds, whatever you call them, westerly anomalies. So you can see back July 17th, the active phase of the MJO traversed from across the Pacific. Also notice the smattering, these little things are, the little red comma things are tropical storms focused around the active phase or westerly anomalies of the MJO. That doesn't mean that they don't happen in other places, but this solid red contour is the active phase of the MJO. But here's today, the 14th, the inactive phase, the dotted contour, is what is now making its way across the Pacific with the blues, easterly anomalies in control. Another active phase is forecast to try not even to quite make it into the Pacific the end of August into September. Notice the other models were saying very weak active phase. Easterly anomalies pretty much holding in control. We'll see how this evolves over the next couple of weeks, but this is not looking like a strong active phase, not a super clear, obvious swell producing active phase, but it certainly will be better than this dead period that we're forecast to go through for the next about 2 weeks. And then finally, the 3-month CFS model. All right, whole planet on one chart. Dateline, where are we? Right there, running right up the middle of the chart. Kelvin wave generation area starts about 135 east right here and ends at 170 west right about there. Okay, this is past performance down here. This is the forecast here. The thing that obviously grabs your eye is this big patch of blue. These are easterly anomalies. Controlling, well, the date line is right there. That's not good. The Kelvin wave generation area. Now, this is interesting. Sort of a battle of easterly anomalies filling most of the Pacific from the date line eastward. Westerly anomalies trying to get a good nose into the far west Pacific, but not quite really getting there. We'll overlay the MJO, just sort of take a look. Here is our current, the dotted contour is the inactive phase of the MJO. From now through about, the Kelvin wave generation area ends right about there. So August 31st, something like that. And then starting in September, the solid contour, active phase moves in control, westerly anomalies, almost the whole month of September. And then is supposed to continue, just very slowly plodding its way across the Pacific. But notice no real westerly anomalies associated with it. Once the active phase leaves the maritime continent, Bali in that area, it's weak and gutless and doesn't have a whole lot associated with it. Let's overlay the low pass filter. Maybe that will tell us a few things. All right. So then on top of all that, there's this high pressure, low pressure bias thing. We call it the La Nina El Nino indicator. This solid contour is the low pressure bias. It in and of itself isn't really low pressure, but it favors the production of low pressure systems wherever it is. And right now it's pretty much been over the maritime continent, and the high pressure bias, 1, 2, 3 contours, has been in control. This is the La Nina indicator, if you will, and it's still hanging on right over California. California is 120 west, okay? But starting at the end of August, it's supposed to shift back and unfortunately be sitting right over top of the date line, building to 2 contours as we get into November. So it sort of looks like a resurgence of La Nina with the El Nino indicator, the low pressure bias over the maritime continent. So pretty much a classic return of La Nina syndrome. We don't think it's going to be nearly as strong as what we went through last winter, but again, not particularly favorable for storm production. That doesn't mean we won't have storms. Clearly we did last winter, and pretty epic run for about 5 weeks until it all shut down. Probably that will not happen this year, but we'll see. You just never know. And with that, let's start looking out longer in the El Nino, La Nina for evidence of either of those occurring. All right, so we start out again looking at the TAO buoy array. This is the East Pacific here, West Pacific here, but we're looking down into the ocean now, down 100, 200, 300 meters. We're looking for the presence of Kelvin waves or the balance of warm water and cold water in the Pacific. Absolute temperatures here in centigrade, 29 degree isotherm. Pretty much locked where it was 2 weeks ago at about, 175 east. 28 degree isotherm. I think it had made it at one point. It was over at 160 west. It's backtracked to 170 west. Past couple days, it's maybe inched a degree or two off to the east, but no significant movement. The 24 degree isotherm limited to, we'll say, 118 west. So warm water pretty much balled up in the West Pacific, and not a whole lot of warm water in the East Pacific. But that's actual temperatures. It's the anomalies, differences from normal for this time of year. This really tells the picture. 1 to 2 degrees centigrade anomalies in the far West Pacific, not even, where is it? 160 west is right there. So the date line. So from the date line westward is your warm water. Sort of syncs up a bit with that low pressure bias, Then eastward, a quickly fading thin pool of 1 degree or less warm water, limited to the surface. Now there is, by the way, these are the anchor lines on the buoys, and the X's are the sensors on those anchor lines. 2 degree below normal temperature. This wasn't here last time I did the video 2 weeks ago. Starting to build. Looks like sort of a cold Kelvin wave, if you will, trying to develop. Perhaps the resurgence of La Nina starting to manifest itself, at least per this model. Here's another model that paints a far starker picture, and it did this even 2-3 weeks ago, saying there's literally no warm water left in the East Pacific. Cold water in control at depth, warm water limited to the far West Pacific, and that is probably closer to the truth. This sets you up with the classic cold water in the East, high pressure above it, blocking high pressure in the Gulf of Alaska, northwest winds along the California coast, upwelling, plummeting temperatures, and again, storms have a hard time forming in cold water with no evaporation and with the jet stream being pushed well to the north. So this kind of gives you a hint of what's going on. The sea level anomalies, another way to gauge what's going on down in the ocean. This is the height of the ocean relative to the normal sphere of the Earth. All right, what are we looking at? South America there. There's the Galapagos right there. Central America, Mexico, Hawaii right there. Equator here. Dateline there. New Guinea there. All right, so what we see is -5, -10, that's centimeters. The ocean height is below normal by about 10 centimeters. It's not a lot, but cold water contracts a little bit, creates a divot on the ocean surface. If you get building trades, they sort of scoop out some of the water and push it off to the east. You notice you have your above normal sea heights over here in the far West Pacific, driven by trades pushing that way and all warm water pooled up at depth here. As long as the trades are blowing stronger than normal, Kelvin waves can't form. You can't get that warm water pushing east. We need something to break up, and this is the classic La Nina cycle. Nothing surprising here. We were hoping we wouldn't get into a 2-year bout of it, but looks like it's building, setting us up for a transition, or if we're not already transitioned towards a La Nina pattern. Upper ocean heat anomaly. It's just basically fancy words for, well, where's the hot water and where's the cold water in the Pacific? This is the far West Pacific here. This is the East Pacific, like this would be Ecuador here on the equator, 2 degrees north and south of the equator. This would be over New Guinea, even further west than New Guinea. Back in time, October 2020, warm water all pulled up in the west, cold water. So Hawaii's at 158, so just a little bit east of Hawaii on the equator, the peak of La Nina, and then all of a sudden in March, boom, Kelvin wave number 1, Kelvin wave number 2, driven by the active phase, the MJO, Kelvin wave number 3. This is all part of the seasonal transition. We got a little headway. All the warm water in the west was discharged, and now instantly, boom, back to the trade. The trade winds return. Water temperatures start decreasing, you notice, and warm water start building again in the far West Pacific. Again, suggesting, well, here is the return of La Nina as we get into the fall. But again, it is the interface between the atmosphere and the ocean, right at the ocean surface, that boundary. That's what really matters. Looking down on the surface gives you a hint of what's to come. And, Kelvin waves take 3 months to work their way across the Pacific. So you can get a sense maybe 3 months out of what's going on in the Pacific. But ultimately, the ultimate decider is what's manifest at the ocean surface. All right, so sea surface temperature anomalies, differences from normal for this time of year. Chile there, Peru, Ecuador there, the Galapagos, a couple of freckles right there. Central America, Mexico, and Hawaii right there. Warm water you can see off of Central America, down off of Ecuador, and down even off of Peru, but it makes it to about 100 west, maybe 105 west, and really no further. And it's only 5 degrees north and south of the equator, on the equator, that really matter. And you see cold water, signs of definite upwelling in this area, and stronger than normal trades just pulling cold water up from depth to the ocean surface, and then the pre-existing cold pattern that's been in play for, I think it's coming up on 3 years now. Now this is also interesting. Warmer temperatures off of Baja, warmer temperatures up into San Francisco, almost up to Cape Mendocino. We're not going to focus on that too much because right now there's just big high pressure out there. It's dead air. It's the sun baking the ocean surface. But there was this strong, cool outflow from north winds circulating around high pressure centered right there. And that's the outflow boundary. But notice it's kind of become detached from the California coast. It's probably a temporary reprieve, but for the moment, enjoy the warm water while you have it, even up into Northern California. Temperatures are quite bearable for a change after being so cold this past spring and the first part of the summer. Kind of normal, kind of good for now. That'll probably hold as we get into about November or so, and then the coolness will probably begin again. Sea surface temperature trend, the continually unchanged pattern. Cool, the blues are cooler than normal. It's just on the equator that really matters. Ecuador right there, cool almost, well there's Hawaii, so almost out to a point south of Hawaii. This is just the 7-day trend, cooling waters but not warming, little pot and pretty much neutral from there on the way across the Pacific. And then the backed off view again, a little smattering of warm water here along Central America and Ecuador. Not too bad. This would be the Nino 1.2 region. The official El Nino monitoring region, they call it the Nino 3.4 region, from 120 west out to 170 west, 5 degrees north and south of the equator. You draw a little box around there, and all you really see is cooler water, a couple little smattering pockets of light warming, but this sort of smells of La Nina, and it has for quite a while. Here's the actual index, the values in the Nino 1.2 region, that region right there around along the Galapagos and Ecuador. You can see temperatures since mid-June have hovered 0, right about dead neutral. And then a week ago, boom, they just fell off a cliff. They're down 744 thousandths of a degree, so effectively 3/4 of a degree below normal as of today. The impending sign, more than likely, of La Nina. In the official El Nino monitoring region, we were doing pretty well. We got temperatures up to 1/3 of a degree, a little bit more above normal. But then they too fell off a cliff. Not horribly bad. 181 thousandths of a degree below normal. So effectively 0.2 of a degree below normal. So that's not even in La Nina territory for the moment. And that is good news. So what does the atmosphere think is going on? You know, we've talked down in the ocean. We've talked at the ocean surface. We've talked the MJO and Kelvin waves and all these large-scale atmospheric things that force water and force things to move around. What does the atmosphere think is happening, right? It is, we keep talking, it's the interface between the ocean and the atmosphere that drives everything. So we look at pressure patterns, and these are not, there's a high pressure here, there's a low pressure there. It's just general across the Pacific Basin and across the Indian Ocean. Where is high pressure and where is low pressure? The high pressure, low pressure bias, if you will. Okay, so we look at the difference, and this is very gross scale, between Tahiti, that represents the West Pacific, and Darwin, that represents, we'll say, the Indian Ocean or the Maritime Continent. If pressure is lower over Tahiti over time, then the index goes negative. If it's higher, then it's positive. Today's value, about neutral, 0.49. But you see, well, we had some pretty positive readings. We had some negative readings. But in general, 30.41. In general, the balance has been positive for the past month. So we can average all this together and do a 30-day running mean to get a clearer, less noisy view. And today the value is 6.31. It was up to 14, here we go, even higher. So this would have been the inactive phase of the MJO. The numbers went high, Then they're falling because we went through a weak active phase, but we know we're moving back into the inactive phase, so we expect to see this to start rising at some point. It's not doing it yet though. The 90-day average, this is the El Nino La Nina indicator, 5.03, and it has been positive, but this guy was up at like 15, plus 15 last fall. It fell and is still falling, but it's got 90 days worth of data on it. By the time this thing moves significantly one way or the other, you're either in an El Nino or a La Nina or somewhere in between. But right now, suggesting, we'll say neutral, biased weekly La Nina. And then finally, the official CFS version or CFS forecast for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region. So where are we? We're in August, mid-August, so roughly about there. Temperatures, this says 0.4 of a degree below normal. Other data we saw showed, 0.3 or 0.2 of a degree below normal. The forecast, this is the raw, ungroomed version of the model, suggests temperatures, this is the worst case scenario really, temperatures going down to, we'll say 0.8 of a degree below normal, and half a degree for 5 consecutive months is the beginning of La Nina. So not even really an official La Nina, though everyone's saying we're good. Atmospherically, it will be La Nina. Ocean-wise, looking at the temperatures, we're already in some flavor of La Nina. This little bump here, we didn't really recover. So down again as we get into about mid-November, temperatures 0.75 of a degree below normal. But from there, warming up, and as we get into the spring of next year, a return to a normal pattern. The PDF corrected, probably the more accurate version, says temperatures only going down to maybe 0.7, so just 0.2 of a degree below the La Nina threshold at its worst, and that's going to happen in a couple of months, 2 months, something like that. So, and then maybe going above normal as we get into April. So this double dip La Nina, not looking too horribly bad, but still, it's La Nina just the same. So for right now, yeah, there's a little bit of swell in the water. It's fading out. A little bit of hurricane swell maybe for Southern California for a day or two. And then stronger swell is forecast. Not super large swell, but respectable, good, solid, longer period Southern Hemi energy from a decent direction that's shadowed for California. Probably better in Hawaii. Certainly Tahiti got their share. That's supposed to happen for Hawaii the earlier part of the week, California the later part of the week. Certainly rideable, but then after that, things supposed to really quiet down. Inactive phase of the MJO takes over, pretty much locks us down for the rest of August. Next decent window of opportunity, probably the month of September, and probably later in September. And by then, maybe we could be in a position for not looking at Southern Hemiswells, but maybe something from the North Pacific. That's always preferred, at least in Northern California. Much more consistent, certainly. Not 20-minute waits between sets, but you take what you can get. Other than that, wind swell in the mix for the middle of the week and beyond kind of thing. Nothing huge, though, and mainly all just north of Point Conception. Beyond that, the inactive phase, the MJO, setting up for the rest of August, and then active phase in September. Beyond that, La Nina this winter. You've heard us talk about that before, so no real change. The good news is maybe not so strong of a La Nina, maybe just barely a La Nina. So that is somewhat encouraging. We think that once we're through that it'll all be a much better place starting about March or April of next year and for multiple years beyond that, assuming we don't instantly transition to some El Nino thing, because typically right after El Nino, you fall right back into La Nina. So it'd be nice to have a couple of years of neutral biased warm after that, but way too early to make any speculations around that. All right, if you enjoyed the video, give us a thumbs up. We'd appreciate it. Comments, questions, concerns, just write it out. Give us the comments there on the YouTube channel, and we will respond as quick as we can. If you haven't subscribed, please subscribe, ring the bell there. You get notified when we update the forecast. If not, go to stormsurf.com. You can there at the top page of every page will provide the link to the video. You can get to it that way. And that's kind of it. All the images that you saw tonight are available on stormsurf.com. So you go there, make that your one-stop shop for getting oceanic weather information. All right, so that's it for this week. We will do it again next week. Same time, same channel. Stay safe. Go get some surf. Thank you.